All right, POE students, I'm going to go over the Beam Deflection Lab quiz. You should have received an email that has unique numbers for your materials for your quiz. I just emailed some numbers to myself, so these are just numbers, unique numbers for me. You should use the unique numbers for yourself. So my numbers were 3.708 for H1, 8.33 feet for L3, 145 pounds for W4, and 3.010 inches for H7. You're going to click on this link right here to get the quiz itself, and you want to make sure that you submit your answers that you have in these spaces that are provided here for your answers. Okay, I'm going to go ahead and do it in Notability just so I can write on this and show you, but you want to make sure that you actually submit your answers in the spots that you're given. Okay, so question number 1 is the top of a beam is 4.453 inches above the floor when no one is standing on it. When Jimmy stood on the beam, the top of the beam was H1 inches above the floor. So H1 was the number that I got, okay, in my email that I received, okay, this email right here. So 3.708 was the distance above the top of the floor, okay. So I can put 3.708 inches is how far it was. So basically what that's saying is you've got a beam, okay, and the distance from the floor, okay, to the top of the beam was 4.453 inches, okay. And then Jimmy stands on the beam, okay, and the beam deflects. Okay, it bends. Exaggerate a little bit there, but now the beam is closer to the floor. And for my number, I got it, instead of it now it being 4.453, now it is 3.708 inches. So you've got a different number for that, the numbers that were written to you. But regardless, that's how you solve the problem. We want to know how much did it bend? Well, just subtract. 4.453, everyone will use that number, and then subtract the number that you were given. For me, 3.708. Okay. Let's see. There it is right here. For me, I already did this math. 4.453 subtract 3.708 and I get 0.745. My answer, 0.745, and you're going to type your answer in. Okay. The next one, the cross section of the beam is 1.452 inches by 3.415. You guys, everyone got the same numbers on this, so everyone's going to get the same answer for number 2. What is the moment of inertia? We're looking for the moment of inertia, and it's in the plank position. So that's why when I drew this plank, I drew it with 3.415 on the bottom as the base and 1.452 as the height. Because in the plank position, the base is always bigger than the height. Okay? Our equation that we are using for this is moment of inertia equals base times height cubed, divide by 12. So plug your numbers in. Your base, 3.415 times the height cubed, 1.452 cubed. Don't forget to cube that. Divide by 12. Okay? So here's Desmos, and here it is right here. 1.452 cubed times 3.415 divided by 12 gives me 0.871182. I'm going to round that off to 0.8712. 0.8712. And is given as inches to the power of 4. This was given in inches. Okay, the length of the beam is L3 feet. So again, look at your numbers. L3 for me is 8.33. So we've got 8.33 feet for 1. Our conversion for this is we're converting from feet to inches. We need to have inches to do our formulas, our moment of inertia and our maximum deflection. There are 12 inches per feet. Feet cancel out top and bottom. We've got 8.33 times 12. 8.33 times 12 is right there. 99.96. 99.96 inches. So 8.33 feet is 99.96 inches. Again, you guys have a different number for this. Don't use 8.33 for your problem. Use whatever problem you got for L3. Okay, the second number that's on the email that I sent to you. Next question. Jimmy weighs W 4 pounds. Okay, well, let's see how much Jimmy weighs. W4 is 145. Jimmy weighs 145 pounds. 145 pounds. What was the modulus of elasticity is what we're looking for the beam. So modulus of elasticity, I put these formulas up here. Okay, I already wrote these out. So this is the formula for the maximum deflection for the beam. Triangle max equals force times length cubed. Okay, triangle max is the maximum deflection. Force is the weight of the person. Length is the length of the beam in inches. We figured that one out in number 3. 48 is 48. E is what we're looking for, and I is the moment of inertia, and we are working in the Planck position. We figured out the moment of inertia in question number 2. It was 0.8712. So we're looking for the modulus of elasticity, which is this right here. Okay, the E. If we algebraically move these around, okay, you're going to get this equation here on the right-hand side. This equation, okay, to calculate E. The reason why I put E on the left-hand side is because over here in this equation on the left, okay, this equation, I've got E on the bottom right here. Okay, if I leave E on the right-hand side of the equation and I move everything over to the left-hand side, I'm going to end up with all the numbers on the left-hand side equals 1 over E, which you can solve for that by using the reciprocal of 1 over E, just flipping everything over on the opposite side. But most people find that more difficult than just moving E to the left-hand side by multiplying both sides by E, okay, which would cancel out E on the right-hand side, and then divide both sides by the maximum deflection, this triangle max. And this is the equation you get. When you do that, you're going to get E equals, again, these numbers are going to be different for you. The weight of Jimmy for me was 145. The length was 99.96. Okay, I'm going to cube that. I'm going to divide by 48 times the moment of inertia. That was question number 2. 0.8712 times the maximum deflection. That was question number 1. 0.745. So you're going to have different numbers for a lot of these. You're going to have a different number for the weight. You're going to have a different number for the length. And you are going to have a different number for, let's see, the maximum deflection. Question number 1 was different because everybody had a different H1 value. I had 3.708. Okay, and when I do this, I get modulus of elasticity. I already worked it out. I'll show you how I where I punched it in. I worked it out and I got right here this answer. 4,648,698.37 is the modulus of elasticity for my beam. Okay. Yours is going to be different. Number 5, what is the moment of inertia? Again, we're looking for I for the beam. Now it's in the joist position. So we have the same equation. I equals base times height cubed divided by 12. Okay, so we have the same dimensions because it's the same beam, but if you notice now the height is 3.415 and the base is 1.452. And when I'm comparing that to question number 2 right here, where the base was 3.415 and the height was 1.452. We call this plank or horizontal. In this question now it says it's in the vertical position or joist position, so we have it's tall and skinny, but with the same measurements, just in a different place. So we go 1.452 times 3.415 cubed divided by 12. Here it is, 1.452 times 3.415 cubed divided by 12, 4.819. Where am I going to put this one? Equals 4.819. That is the moment of inertia in the joist position. Now, how much would Jimmy deflect the beam? So we're looking for maximum deflection. Okay, we're looking for triangle maximum deflection in the joist position. So we just figured out the moment of inertia in the joist position. So we're looking for, we're going to use this equation, the delta max equation right here. Right here. Delta max, maximum deflection is what that is, equals force times the length cubed divided by 48 times E times I. That's our equation. So I've got the weight of Jimmy is 145 times the length of the beam, 99.96 cubed, divided by 48, never changes, times the modulus of elasticity, which I figured out up here in the question number 4, right here. And we just figured out the moment of inertia right here for the beam in the joist position. Okay. How much will it bend? If I do all this math, I think I got it here yet. There it is, right here. 0.13. 0.135 rounded off. Okay. Here we go. Another question. Allison, a different person, stood on the same beam in the plank position. Top of the beam was H7. H7 for me is 3.010. 3.010. Oh, hang on. 3.010. 3.010 above the floor. What was the deflection caused by Allison? So when she stood on the beam, it's going to be the same beam as we had in the start here, question number 1. Okay, so we have the same beam as what we have up here. So it's going to be 4.453 inches off the floor. Oops. 4.453 from here to here. 4.453. Allison stands on, that is Allison right there. It does not look like Allison, but it is. Look at, she's got a smile. Nice hair, curly hair. Okay, so when she stands on it, the beam bends. Okay, so now it's bending, and now instead of it being 4.453, it is my number 3.010. Okay, from the floor to the top of the beam. Just subtract 4.453. Everyone's using that number. You put your number in here for H7 from the email you got. And I guess I don't have that one. So 4.453 minus 3.010, 1.443. 1.443. Okay. And the last question is, what was Allison's weight? Okay. In order to calculate Allison's weight, we're going to use the maximum deflection equation again. This equation right here. That's the way it sets up. You got the maximum deflection equals force times length cubed divided by 48 times Young's modulus times moment of inertia. We are going to calculate for her weight. There's a problem we did in the lab. It was just like this. You can calculate her weight by moving these numbers around. And in this case, since F is on the top on the right hand side, we're going to move everything to the left hand side. Okay, so we're going to move 48 times E times I. Okay, so 48, let's enlarge this, times E times I, and that's going to balance these, or cancel these out. But whatever we do on that side, we have to do on the other side. So I'm going to put 48 times E times I on this side, and then we are going to have to divide by L cubed in order to get the F by itself. And whatever we divide by over there, we have to divide by over here, L cubed. Okay? And that's the equation that I had set up right here already. Okay? That's how we get to that point. Here are my numbers. 48 times 4,648,698.37 times times the moment of inertia times the maximum deflection divided by the length cubed. Okay, and we got 48 times 4,648,698.37 times, what else am I multiplying here? 0.8712 712 times the deflection was 1.443, and we are going to divide this by the length cubed, 99.96 cubed. So we get 280.85. .85. So Allison weighs 280.85. Number 9, the stiffness of the beam's shape is the moment of inertia. And this is the symbol for moment of inertia. It's the letter I. Okay, the letter I. And this right here, there's two answers. The stiffness of the material This is dealing with the chemistry of the material. Is the modulus of elasticity is capital E, and here's the words. And then how much a beam bends is its deflection, also called the maximum deflection or triangle max. Okay, those are your 3 problems. There's also going to be a question on the test that is dealing with the composite shapes. So, for example, you may remember that we have I-beams and we have regular beams. Okay, why would we use an I-beam like this instead of a regular beam? Because the I-beam uses less material. Okay, so we've cut out all this material here, so we can use an I-beam or another shape of a beam that uses less material, and it doesn't really lose that much strength compared to the regular size beam. So the regular size beam, like this one over here, if you may need to have the strength of a regular beam, but if you don't need to have the strength, you can use an I-beam. Okay, you can go over that and review that in your notes, and because there will be a couple questions on that as well. So good luck on this, and let me know if you have any questions.